This video goes through the differentiation of the natural logarithm function. Now, our QCAA subject matter is to establish and use the formula d dx of ln of x is 1 over x and d dx of ln of f of x equals the derivative of f of x over f of x. Now, this formula, the first one, is on your formula sheet. The second one is the shortcut, not on formula sheet. But could use the chain rule if you don't remember it. Let's start with the proof, and that's a proof not using differentiation by first principles, so you've got to love that. If we have y equals log base e to the x, so remembering log base e, that's the same as ln of x. Now, to differentiate it, we go to an exponential. So we go rearrange to make x the subject, x equals e to the y. Now we differentiate both sides with respect to x. So d dx of x and d dx of e to the y. Now to differentiate x with respect to x, it's 1. To differentiate e to the y with respect to x, it's e to the y times by dy dx. Now, this is definitely going into specialist maths territory. So specialist maths students will understand this a little bit more. But off to the right, I have using the formula, which is the shortcut for e to the f of x. Okay, so instead of f prime of x, or that derivative, you've got that dy dx there, right? So now if I rearrange to make dy dx a subject, so we divide both sides by e to the y, we end up with dy dx equals 1 over e to the y. From there, we started by saying let x equal e to the y. Well, there's your e to the y there. So I can replace e to the y with x. So that means dy dx is 1 over x. Now, remember, for your natural logs, or any log for that matter, that x had to be greater than 0, right? If you think about your natural log graph, or if you don't remember your natural log graph, it looks like that. So you have an asymptote at x equals 0, and x is greater than 0. And that point there is 1. So let's come up with that shortcut. Use the chain rule to differentiate y equals ln of 8x. Now remember, you only have on your formula sheet that d dx of ln of x is 1 over x, right? You can learn the shortcut, or you can use a chain rule. So chain rule, let u equal ax, which means I now have y equals ln of u. Differentiate both, du dx is 8, dy du, using what's on your formula sheet, that would be 1 over u. Formula for the chain rule, which is also on your formula sheet. Substitute what you've got, so you've got 8 multiplied by 1 over u, which is 8 over your u is 8x. Now note, the 8's cancel, so that gives you 1 over x. Now note, that's going to happen all the time. If you've got ln or y equals ln of 100x, Your dy dx is the derivative of the function. So 100x is 100 all over 100x. Hundreds cancel, you're left with 1 over x. If I have y equals a function of x, let u equal f of x. That means y is ln of u. Differentiate both. Du dx is f prime of x. Dy du is 1 on u. So dy dx is du dx multiplied by dy du, which is f prime of x multiplied by 1 on u, which is f prime of x over f of x. So that's the shortcut. So let's do some examples. Y equals ln of 5x. Now you could just remember it's going to be 1 over x, or you can go look at that function. Derivative of that is 5 over 5x, which becomes 1 over x. Next, I would write it as y equals 3 ln of x to the half. So dy dx equals your 3 multiplied by the derivative of what's inside is 1 over 2x to the negative a half. Then that's all over x to the half. So now we have 3 over 2, x to the negative a half divided by x to the half. Your highest power is at the bottom, so that's where it's going to stay. 1 half take negative a half is 1 half plus a half, which is a whole. So you have 3 over 2x. Now, if you're struggling with that, remember you can use the chain rule. It's a good thing to rely on and fall back on if you're unsure. If you let u equal x to the half, you have that y equals 3 ln of u. Du dx is a half x to the negative a half. Dy du is 3 over u. Dy dx is du dx multiplied by dy du, which becomes a half x to the negative a half multiplied by 3 over u, which is 3 over 2 x to the negative a half over x to the half. Back to where I started, always thinking about where your highest power is, because that's where it'll end up. So the half take negative a half is a half plus a half, which is 1. So that's how you get that 3 over 2x. Personally, I think the chain rule can be very straightforward. It takes out a lot of cognitive load to use. It does reduce it to something that's very simple. So this one, again, if you just think the shortcut, you've got the derivative of the top, 50x to the 9 minus 24x, and that's all over that function. You could factorize. I probably would just leave it like that. If you were using the chain rule, let u equal 5x to the 10 minus 12x squared plus 6. Y equals ln of u. Du dx 50x to the 9 minus 24x. Dy du is 1 over u. Dy dx is du dx multiplied by dy du, which is your 50x to the 9 minus 24x all over u. And you could skip some of these steps as well. All right. Personally, the shortcut should be when you're using it within something. So if you're using your product rule or your quotient rule, that shortcut is going to make your life very easy. If you have a straightforward question like this, you would be expected to use the chain rule. Now, the next one, I would definitely use chain rule. If you let u equal ln of x, you've got y equals u squared. Differentiate both. Du dx is 1 on x. Dy du is 2u. dy dx equals du dx multiplied by dy du is 1 on x multiplied by 2u, which is 2 ln of x all over x. Don't discount the chain rule. Don't think, oh, it takes too long. Chain rule is very straightforward. It's nice to use. I personally use the chain rule quite a lot rather than shortcuts because the shortcuts are things that you have to remember. Okay, chain rule is a process. Chain rule, you'll always be remembering, you'll always be using what's on your formula sheet. So you are decreasing your cognitive load using the chain rule.